Hello everybody. What we have here is 240, page 9 of the notes. Here's some definitions starting out right here. I'm going to encourage someone to pause this right now so you guys can copy this. So please do that. Pause it so you guys can copy it. Okay, so you should have all this copied down here. Revolution is the sun. Earth traveling around the sun. Rotation is the spin of Earth on its axis. Insolation, we've said this before, insolation with an O is incoming solar radiation, another word for sunlight. Year is Earth going around the sun once, or any sort of thing going around the sun once. Apparent motion is how it looks like it's moving. We say that the sun, the apparent motion of the sun is that it rises and sets through the sky. Now, it's not actually, the sun is not actually going around Earth, but that's the way it looks for us on Earth. Zenith is our location directly overhead, 90 degrees up from the horizon. That's what the zenith is, a point directly overhead. The horizon is where land meets the sky. I'll show you some pictures of that in just a second. Solar noon, every day has a solar noon. It's the highest point that the sun reaches during that day. It's right around noontime, daylight savings time, the clock's jumping ahead. It changes it to be around 1 o'clock sometimes, but it's really usually around that time. Strongest sun is during that time. Duration of insolation. Duration means how long. Insolation is sunlight, so it's length of daylight for that particular day. That also changes every day by a few minutes for us, and it depends on date and latitude. So that's that. On the next page, we have this. Okay, horizon. The horizon. In this case, in this picture, I'm going to move the line here to show onto the horizon. That's the horizon right there. What I'm calling where the sky meets the ocean. In this case, not a great drawing line, but. Here's another example of the horizon, okay, I'm going to move that right there. That's the horizon for this picture. And I think I have another one. Oh, this one, same picture again? I don't know, but either way, that's the horizon. Okay, sometimes you have to think about the horizon. If you have a diagram, where is the horizon going to be for that person in the diagram? That's important. What else do we have here? We have, okay. Please copy this down and pause it as well. Someone should pause it as you copy it down. Okay, you should have this down. Intensity of insolation, how strong the sunlight is. This is going to be the cause of the seasons. The cause of the seasons on Earth. It is not because when we're closer to the sun, it's hotter, and when we're further, it's colder. It's not that. As a matter of fact, we're closer to the sun in January, we're furthest in July. That's true. It is because of this we're going to learn today. Very important. It's the angle of insolation, the angle that the sun is hitting the land. The more direct the sunlight, the hotter it is. And when the sun hits Earth at a low angle, it's more spread out, cooler. Here's my drawing here. I took these lines here. It's the same amount of lines, same width. When they're straight down, they're very concentrated. It's going to be very strong sunlight. If they're hit at a low angle, it's much more spread out, more kind of area that it's hitting. Therefore, that same amount of sunlight, not as strong on the ground because it's spread out over a larger area. And this is similar when the sun is setting at night, for instance, even on a hot day. The sun is not as strong. Closer to noontime, the sun is higher in the sky. Probably not this for us, but higher. That is key. That's what causes the seasons. Let's see how that happens based on the curved nature of Earth. The curved surface of Earth causes the angle of insolation to be different. So what I want to point out here is that at this location A right here, look, so this amount of sunlight, that width of sunlight, is concentrated on that area, okay? And at this other location, I'm going to use a different color for it just to separate it. I'll use red here. Now, that same amount of sunlight, because it's curved up here, is over a much wider area. So the sun, if you are a person on Earth right there, I'd say this standing like this, the overhead is here, the sun's going to be low in the sky. But if you're this person here, The sun is more directly overhead, warmer. So in this case, nice beeping over there of the, hold on. Okay, that was annoying. Here we go. So this would be like more winter for them, summer for them in this orientation. Okay, what we have here. What causes the change in seasons? The tilt of Earth's axis affects the angle that sun hits the Earth, called the angle of insolation. In summer, there's more direct sunlight and warmer. Winter, sun is lower in the sky, less direct, cooler. Someone should pause this so you can copy it right now. Okay, we're back. Here we go. What do I have here? I'm going to look at this. Notice how when Earth revolves around the sun, the axis, I drew the axis here in red. Now you don't have this picture, so you're not copying it. In red, and it's always kind of tilted the same way. We'll call this, like the Earth, the axis is tilted towards the sun, meaning the North Pole, towards the sun. We'll call this away from the sun. We'll call this neither towards nor away, because it's kind of towards the side. We will do more of this. Let's just get some of these things down. Like, let's really get the season. Winter, this you do have in your notes. Winter, let's copy this down. Whoa, where is it? Where is it? Nope. Here we go. Winter in the U.S. So, if you pause the video to copy this, do that now. Okay, you should have that copied down. Winter is going to look like this. Okay, axis tilted away from the sunlight. North Pole tilted away. We're here. Notice, this would be overhead. The sun's low in the sky. For someone down there, the sun is pretty dead on. It is summer for them. When it's winter for us, summer for someone south of the equator. Interesting point. Okay? That's key. And the bottom of this page, please pause it and copy this down. Okay, we're back. First day of the winter season. This is stuff you will have to know. You'll have to know this, so it requires some memory. Okay, first day of winter season is December 21st. It's called the winter solstice. Some years it can be the 20th, some years it can be the 22nd, but most of the time it's the 21st of December. The sun is directly overhead in south of the equator, 23.5 degrees south. It's called the Tropic of Capricorn. We have about 9 hours of sunlight for us that day. 24 hours of darkness. The North Pole has 24 hours of darkness on that day. The South Pole has 24 hours of daylight on that day, which is interesting. We'll talk more about that in class. The angle of insolation at solar noon in New York State, the highest it gets on that day is 24 degrees above the horizon. Okay, not very high, low in the sky, low angle, therefore not warming the surface very much, and that is why it's cold in the winter. Know that number, that's why that's starred. I'm going to stop this video now, pick up with part 2.